Hi you guys, let's talk about rational numbers in decimal form. So here's some vocabulary. The first one is a rational number. Anytime you hear me say rational number, see the first 5 letters R-A-T-I-O? That means ratio. So it's any fraction, any number over another number. So some examples would be -5/18. That's a rational number. Or 17/3. That's a rational number. Okay, terminating decimals. Well, to terminate, anything that terminates stops. So this is a decimal that stops. For example, 0.35, it stops. It doesn't keep going and going. A repeating decimal is a decimal that repeats in a pattern. So, for example, 0.121212 ... It would keep going 1 and 2 forever. And we use a bar to show somebody what's repeating. So a better way to write that would be 0.12 with the bar over the 1 and the 2. Okay, so let's look at example 1, writing fractions as decimals. A trick I like to use, and you've heard me say it before, in and out. So watch how this works. Look at letter A, 8/11. Well, think of it as In-N-Out burgers, in and out. So the 8 goes on the inside and the 11 goes on the outside. Now, when I put the number 8, remember you have to put the decimal after it so you can see it, and bring it straight up so you'll see where it goes in your answer. And then I always tell my students to add 3 or 4 zeros. Sometimes you need more, sometimes you need less. So it just depends on the numbers you're dividing. And then you divide. 11 won't go into 8, but 11 goes into 80 7 times. 7 times 11 is 77. 80 minus 77 leaves me with 3, and I bring down that second zero. So 11 into 30, well, that would go 2 times. So 2 times 11 is 22. So I subtract 30 minus 22 leaves me 8. I bring down that next zero. So now I look at 11 into 80. Well, that went 7 times. 7 times 11 is 77. 80 minus 77 gives me 3, and I would bring down that other zero. And you should start to see the pattern, 7, 2, 7, 2, and ... It keeps going. So I want you to write it not where you showed your work. Look at how I wrote it down here. I want you to write 8/11 equals, and then put 0.72 with a bar over the 7 and the 2 only. And of course, that's a repeating decimal. Take a look at B, 9/25. We'll use the trick in and out. Put the 9 on the inside, the 25 on the outside. After the 9, put a decimal so that we can see it, and then bring it upstairs so we know where it goes in our answer, and then add 3 or 4 zeros. Now, 25 will not go into 9, but 25 goes into 90 3 times. 3 times 25 is 75. 90 minus 75 leaves me with 15, and I bring down that zero. 25 goes into 150. Well, think of quarters. It would take 6 quarters to make $1.50. So I put a 6 up here. 6 times 25 is 150. 150 minus 150 is 0, and I can stop. So it's 0.36, and it stops. And I want you to write your answer like this. Grab the fraction, 9/25 equals 0.36, and it stops. You can box your answer. And this is a terminating decimal because it stopped. It didn't keep going. Okay, so now we're going to write the fraction or the mixed number as a decimal. So look at number 1, 9/20, in and out. Put the 9 on the inside, the 20 on the outside. Put the decimal after the 9 and add 3 zeros. Bring that decimal straight up, and let's do the dividing. 20 will not go into 9, but 20 goes into 90 4 times. 4 times 20 gives me 80. 90 minus 80 gives me 10, and I bring down a zero. 20 goes into 100 5 times. 5 times 20 is 100, and I have nothing left over, so I can stop. So grab the fraction, 9/20 equals, and now write it, 0.45, and box your answer. This is a terminating decimal. It stops. Take a look at 2, 1/3. Do the in and out. Put the 1 on the inside, the 3 on the outside. Put the decimal after the 1 and bring it straight up. Now, 3 will not go into 1, but 3 goes into 10 3 times. 3 times 3 is 9, and I subtract. 10 minus 9 leaves me 1, and I bring down a 0. 3 goes into 10, 3 times. 3 times 3 is 9. I subtract, I get a 1, I bring down the 0, and I start to see the pattern. 3, 3, 3, 3, 3. It'll continue forever. So now this is how we're going to write it. Grab the fraction, 1 over 3 equals 0.3, and put a bar over a 3 only, because that's what repeats. Take a look at number 3. 2 over 5. Use in and out. Put the 2 on the inside, the 5 on the outside, put the decimal after the 2, and bring it straight up. Well, now 5 will not go into 2, but 5 goes into 20 4 times. 4 times 5 is 20, and I subtract, and I have nothing there. So I know that 2 over 5 equals 0.4. It's a terminating decimal. It stops. Take a look at number 4. If they give you a mixed number, 2 and 9 over 11, well, first we have to make it improper. So start at the 11. 11 times 2 is 22, and now add 9. So 22 plus 9 gives me 31 over 11. And now I use the in and out. So I put 31 on the inside, 11 on the outside. And I put the decimal after the 31. I bring it straight up. And notice how I added 5 zeros. Okay, so 11 goes into 31 2 times. 2 times 11 is 22. I subtract. I get 9. I bring down the first 0. 11 into 90. Well, that'll go 8 times. 8 times 11 is 88. 90 minus 88 leaves me 2, and I bring down the next 0. 11 into 20. Well, that would go 1 time. 1 times 11 is 11. 20 minus 11 leaves me with 9, and I bring down the next 0. Oh, I've done this before. 11 into 90 goes 8 times. 8 times 11 is 88. I subtract and I get 2. And now you should see that it's repeating. So we have 2.81818181 forever. So this is how I want you to write it. Grab the original number, 2 and 9/11 equals, and now copy it, 2.81 with a bar over the 8 and the 1 only. You're just showing somebody what repeats. Take a look at number 5. 5 and 7/8. We'll make that an improper fraction. Start at the 8. 8 times 5 is 40. 40 plus 7 gives you 47 over 8. And now use a trick, in and out. Put the 47 on the inside, the 8 on the outside. And now after the 47, bring that decimal straight up in your answer so you know where that goes. 8 goes into 47 5 times. 5 times 8 is 40, and you subtract and get 7. Bring down that 0. 8 goes into 70 8 times. 8 times 8 is 64. Now when we subtract, we get 6, and bring down that next 0. 8 goes into 60 7 times. 7 times 8 is 56. When we subtract, we get 4, and bring down that next 0. 8 goes into 40 5 times. 5 times 8 is 40. We subtract and we get nothing. So now grab the original number, 5 and 7/8 equals, and put your decimal, 5.875, and box your answer. Take a look at the last one, number 6. It's 6 and 4/5. So start at the 5 and multiply. 5 times 6 is 30. 30 plus 4 is 34 over 5. And then use the in and out trick. Put the 34 on the inside, the 5 on the outside. Put that decimal after the 34 and bring it straight up so you know where it goes in your answer. 5 goes into 34 6 times. 6 times 5 is 30. Now you subtract and get 4 and bring down that 0. 5 goes into 40 8 times. 8 times 5 is 40, so you subtract and get nothing. So it stops. So grab the original number, 6 and 4/5 equals 6.8, and you box your answer. Okay, let's do guided practice. Write the decimal as a fraction or a mixed number in simplest form. Well, let me show you a really cool trick. Look at number 7. If I give you 0.9, I want you to write 0.9, and underneath the decimal point, I want you to very carefully use your red and put a 1, and underneath any other number after the decimal point, put a 0. So 0.9, I use my red, I put a fraction bar under the decimal of 1, under the other number of 0, so I can see the fraction. 0.9 is the same as, is equal to 9 over 10, and I box my answer. Take a look at number 8, 0.76. Well, I write the number exactly like I see it. Then I grab my red and I put my fraction bar, my invisible fraction bar. Underneath the decimal, I put a 1, and underneath both those other numbers, I put zeros so I can actually see the fraction. So 0.76 is the same as 76 over 100. And now I can reduce. 4 goes into both. 76 divided by 4 is 19. 100 divided by 4 is 25. So I know that the decimal 0.76 is equal to 19 over 25, and I box my answer. Take a look at number 9. -1 and 1500ths, okay, 0.15. Well, see that number in front of the decimal point? That's a giant whole number. So write -1, a giant -1, and then put 0.15. Now use your red and put a fraction bar under the decimal point. And now under the decimal point, put a 1, and underneath the 1 and the 5, put 2 zeros. So you can actually see the fraction. This is -1, see my giant whole number, -1, or integer, sorry, and then 15 over 100. And then I reduce just the fraction because I see 5 goes into both. So I have -1, and then 15 divided by 5 gives me 3 on top. 100 divided by 5 gives me 20 on the bottom. So take the original number, -1.15 is equal to the mixed number -1 and 3/20, and box your answer. Take a look at number 10, -5.25. Well, again, the number in front of the decimal is the big, giant, whole, complete number. It's an integer because it has a negative. So write a giant -5 and then put the 0.25. Now use your red and put a little fraction bar. Underneath the decimal, put a little 1. Underneath those other 2 digits, put zeros. So you can see it. It's -5 and the fraction 25 over 100. And now you know that 25 goes into both the top and the bottom. So I reduce. I have -5, and then 25 divided by 25 is 1. 100 divided by 25 is 4. So I know that -5.25 is equal to -5 and the fraction 1/4.